We have experimented on tens of millions of animals, and we have very little to show for it.
The power of our democracy.
I had a colleague who once said exactly that. I don't care if it takes 1 million rats, to die. As long as it saves one human life, it was worth it. What if people listening or viewing, are thinking along the same lines? Aren't humans top of the food chain? Aren't we the most important species on the planet? Why shouldn't we just kill whatever we need to if it's going to benefit us?
I don't think of us as, at the top of the chain. I think that we're part of this whole planet. We're part of the animal kingdom. And we need to have that common sense, right? We're primates with big brains. We need to use our large brains, use our rational thinking that got us to where we are today, to truly change what we're doing for humanity and for other species on this planet. It's a matter of common sense too, in some ways. And the thing is, we have experimented on tens of millions of animals, and we have very little to show for it. And that's the thing. So are we going to continue to do this, or are we truly going to go through a rough period, embrace change, and start focusing our energy somewhere else? And this is where, I've been fiddling with this for the last little while I was talking to you. This is this new technology. So this would be considered an in vitro technology. This is organ on a chip. And this is essentially a chip the size of a thumb drive. You can see that I'm holding it here, and you can plate small amounts of cells in these little compartments that we have, and essentially capture a microcosm of human physiology in this thing. And this is now being used, the US FDA is testing this technology for drug safety testing. And this is going to revolutionize the way we do chemical testing and drug testing over the next decade. And the work that we do in my laboratory too, we are creating 3D bioprinted human tissue models, and this is essentially what they look like. This is sort of a dried up tissue that's on this petri dish, but we got these petri dishes with these different compartments, and we're developing kidney model, GI model, heart, lung, liver models, where you could capture human biology in this little thing with a couple of million cells.
Huh. Interesting. Now, the Netherlands are going to end animal testing for chemical safety by 2025. Where is the rest of the world? Where are they at this point in time? Are they leaders? And who's lagging? And where's Canada in all of that?
The 2025 deadline has since changed.
Okay.
That came out back in 2016 or 2017 when they made those goals, but that has since changed slightly by another decade or so, I'm going to say. And then back in 2019, the US Environmental Protection Agency said the same thing, that by 2035, they want to end toxicity testing on animals. But those deadlines are not going to be hard and fast. They're going to change a little bit. But in general, yes, the European Union and the United States, they are on a very good trajectory to phasing out chemical testing on animals. And in Canada, we're making some progress. I'm going to say that we don't have the kind of legislation or financial investment in this field, or even, an Animal Welfare Act that is protective for the animals in science in Canada. We don't have any of that, but we are making smaller changes. The Canadian Environmental Protection Act, for example, CEPA, that was amended recently in the Senate, contains language requiring you to reduce, replace, and refine the use of animals for toxicity testing. And once that goes through the House, hopefully we will have that finalized in legislation that we need to move away. And I think the Liberal government in their last election platform did mention 2035, just like the US EPA did, that it would be a good time to phase out chemical toxicity testing. But we don't have that kind of, it's not hard and fast written legislation yet. So we need to make similar changes for studying human disease as well. Chemical testing is a whole other ball game, but understanding, instead of making knockout mouse models of Alzheimer's disease, when are we really going to focus on using human Alzheimer disease in a dish, or heart failure in a dish, that type of thing.
Yes.
So
So when you approached the vice president of research at Windsor back in 2016 with a proposal for the Canadian Centre for Alternatives to Animal Methods, the center now works still in three main areas: biomedical research, regulatory testing, and developing courses and degrees focused on training the next generation to think outside the cage. So how are your students responding? What has the reaction been? Are some students like, no, we need animal models. That's the way we've always learned. We have to keep going this way. Or are they accepting? Are they accepting of it?
fortunately, the next generation is far more open-minded than the current generation or the previous generations of scientists. So I'm very hopeful. No, they're very excited. I mean, look at students today. They have an iPhone 13 in their pocket. Why would they want to resort to animal testing?
Right.
You think about like the very first computer it took up a whole room, and now you essentially have your whole world at your fingertips in a device that's so small. It's the same kind of change. They understand that these technologies like organ on a chip and 3D bioprinting, they are excited. They can see the possibilities, and honestly, it's inevitable. It's going to be their future. So most of my students, every time I give a lecture somewhere, or the ones that I'm training here at the University of Windsor, they're excited. They want to learn more. And even if they cannot completely get away from certain animal studies, they want to try and incorporate some of these new methods. And it requires a different way of thinking. So if your primary way of thinking is, I'm going to take this mouse, knock out a gene, and see what happens, it's not the same kind of reasoning and rationale that goes into taking 3D bioprinted tissue models to mimic a certain disease. It requires a different kind of mindset and experimental design. And these students are doing it very well. One of the exercises I did last year with my class, so we currently offer Canada's first graduate course in this field. It's called The Human Subject, Animal-Free Methods in Biomedical Research and Toxicology. I gave them one assignment and I asked them, if you had to rediscover insulin today in 2022, how would you do that without using a dog model? And some of the answers were amazing. These are master's and PhD students, and the kind of experiments they designed and developed, it was just so refreshing to see that they were open, that given the chance, that they wouldn't resist.